semester the syllabus included discrete distributions, discrete probability distributions. Here I would like to explain what does mean discrete distributions. So, before that, discrete, a random variable which takes countably infinite number of values, that is called discrete random variable. We can count and uncountably infinite also. For example, in a class 30 chairs. So, the students place only 30 chairs, means we can count each and every chair, that is countable. Or in piece of chalk, in chalk box there are some pieces. So, that also we can count. These are the examples of discrete random variable. And now, what is continuous random variable? A random variable which takes infinite interval, means uncountable, that is continuous random variable. Means here how does we can give an example of continuous random variable, that is for example pi, that value is 3.14. So, heights and weights, these are the examples of continuous random variable. And today I am going to explain some distributions. What does mean distribution? A characterization of random variable is called distribution function. So, here random variables which are discrete and its probability distributions is called discrete probability distributions. In your syllabus, some discrete distributions, that is Bernoulli distribution, binomial distribution, geometric distribution and hypergeometric distribution, and there are so many Poisson distribution and negative binomial distribution. But in your syllabus some distributions are there that I want to explain. So, coming to first Bernoulli distribution. So, what does mean Bernoulli distribution? So, Bernoulli distribution has only two possible outcomes, that outcomes are success and failure. We can represent its numerical value, that is success is 1 and failure is 0. So, how? For example, if tossing a coin. So, our assume is if head occurs success and tail occurs failures. So, here success the numerical value I have given, that is 1 and failure the numerical value is 0. So, the probability mass function is here p to the power of x q to the power of 1 minus x, that is Bernoulli distribution. And one more example. For example, in a bowl there are two balls, that is marble, green marble and red marble. So, a person without seeing he can pick up one marble. So, we assume green marble termed as success, a red marble termed as failures. So, first a trial, for example, a person or pick up one marble, that termed as green, our assume is green marble as success. So, we noted it is a success. So, that is. So, ultimately red marble is termed as 0. So, it is 0 1 distribution, and Bernoulli distribution are also similar to binomial distribution. So, what does mean binomial distribution? If a trial repeated number of times, then we call binomial distribution. So, here I want to explain the objectives of binomial distribution and introduction and applications of Bernoulli distribution and some exercises and some problems in your examinations, how the model paper, that also I will explain. So, the main objective of these Bernoulli and binomial distributions are already I explained about Bernoulli distribution. So, here we need to find the parameters of the distribution. Introduction. In unit 1 of block 1, we consider theoretical properties and characteristics of Bernoulli and binomial distribution. Let us consider some situations where these distributions arise. Some numerical illustrations and examples also I can give. So, for example, Bernoulli distribution. Already I explained 2 examples. At the same way here, in a ball there are 2 balls, 2 colored balls. One is white, we can represent as W, one is black ball which is represented as B. So, here we can draw one out of these 2 balls. So, here this drawn can be done with a replacement. You know, in sampling there are with a replacement and without replacement. With a replacement means we can choose one ball and replace before drawing second draw, that is with a replacement. And what about without replacement? If you choose one ball from the urn and keep aside before drawing second draw, then the number of balls also decrease here. So, that is without replacement. Here an example is, in a ball there are 2 balls, that is white ball and black ball. Okay? In this we can draw one ball with a replacement. And what is the probability to get success? Here our assume is white ball is success. So, drawing chosen white ball is called the success. So, the probability of success is termed as here W by W plus B. Why W plus B? According to probability definition, favorable number of outcomes over the total number of outcomes. Here total possible total number of outcomes. So, total number of outcomes is what here? W plus B. In urn contain W, white balls and black balls. So, total number of cases here W plus B. And what is the favorable? Here we are choosing only white ball. So, that is white. So, the probability of success means drawing white ball is W by W plus B. So, in each draw. So, here success is constant for each draw. So, means there is no priority for to draw black ball and white ball, both have the equal probability. One more example. For example, one can know that snakes and ladders. So, how can we play the game snakes and ladders? We can use dice. You know, the dice means it has 6 plausible outcomes. All of you know about the dice. It has 1 dot, 2 dots, 3 dots, 4 dots, 5 dots and 6 dots. So, here I am using pair of the dice, means we have 36 exhaustive cases. Here in this game, then the moving piece takes odd number of positions or even number of positions. Here total possible cases are 36 and probability of getting each case is equal. So, that we can represent P equal to Q equal to 1 by 2. That means what? When you throw the dice, we can get the outcomes like 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. These are same number. So, if you want only odd number, so those are, and only even number, that also represents. Only odd number means 1 1, 1 3, okay, 1 5, like this. Same 3 1, 3 3, 3 5. Same 5 1, 5 3, 5 5. Okay. So, these are the cases. Even number means 2 2, 2 4, 2 6. At the same way 4 4, 4 2, 4 6. Okay. So, those are. So, each having the same probability, that is P equal to Q equal to 1 by 2. Okay. So, now one more example. In business also we can use these dice. So, how enrolling the same number on both sides is considered as a success. I already told dice have 6 faces. So, 2 dice have same number of faces also will represent. There are 36 exhaustive cases. One is same number, one is even number, one is odd number combinations. Here same number of are 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. So, what is this 1 1? We are throwing 2 dice at a time. If we get both the dice have upper outcome is 1 1, that is same number, same. Similarly 2 2, similarly 3 3, similarly 4 4, similarly 5 5 and 6 6. Means will all come at a time? No, any of these 6 possible outcomes, any one will place outcome. So, then the probability is 1 by 6. Why 1 by 6? 6 are the total exhaustive cases of 2 fair dice of same number, and getting any one of them is 1, that is favorable outcome. So, that probability is 1 by 6. And what about the failure? We know that Q equal to 1 minus P. Okay? So, Q equal to 1 minus P, here P value is what? 1 by 6. So, 1 minus 1 by 6, which is 5 by 6. Here we have to check the probability. Probability properties are what? Probability of x is greater than or equal to 0. Total probability is 1. So, total probability here please check. P equal to 1 by 6 plus Q equal to 5 by 6. 5 plus 1 is 6 and total 6. 6 by 6 is 1. So, which is a probability mass function? Means it satisfies probability mass function properties, and also which are countable, which is the discrete distribution. So, why it is binomial? It has only 2 possible outcomes, that is success and failure. Means same number is here success. If you get different number like 1 3, 2 4, 5 6, these are failures. So, that cases are here 5 by 6. Okay? So, that is one more example. Here we take x equal to 1, the numbers on the 2 dice match, and x equal to 0 if they do not match. So, verify that mean of x greater than variance of x. How? Here probability of x is 1 by 6 where x equal to 1. Probability of x, that is q, is 5 by 6 where x equal to 0. So, what is mean? In statistically, mean represents expectation of x. Expectation of x is here p equal to 1 by x. Variance of x is pq. Why p and pq? This is 0 1 law. In Bernoulli distribution, the mean is p and the variance is pq. Here given the p equal to 1 by 6, q equal to 5 by 6. What is the mean? Mean value is here p. So, that value is 1 by 6. What is the variance? pq. So, p is 1 by 6 into q is 5 by 6. So, 5 by 36. So, what is expectation of x? So, already I explained by Bernoulli is 0 1 law. So, expectation of x formula is what? Summation x into p of x. See here what is p of x? P to the power of x into q to the power of 1 minus x. Yes, x values are 0 and 1. So, in the case here see 0 into p to the power of 0, okay, 0 into 1 by 6 plus 1 into 6 by 36. So, total we will get what? 1 by 6. So, x into p of x means 0 into p plus 1 into p. Okay? 0 into p is 0, that is p value is 1 by x, then 1 into p is 1 by 6. So, average value is 1 by 6. Okay? So, that is 6 by 36, which is greater than 5 by 36. Hence, we proved this. Why? Already we find out variance of x is 5 by 36. Here we obtain mean value is 1 by 6. So, it we can write as 6 by 36, which also equal to 1 by 6, and we will compare mean and variance. Here mean is greater than variance. So, it is point to be noted, in Bernoulli distribution mean is greater than the variance. Applications of binomial distributions. So, what is the mass function of binomial distributions? Why Bernoulli to binomial? If a trial repeated number of times it termed as a binomial. The probability mass function of binomial is NCX p to the power of x q to the power of n minus x, where x takes the values 0, 1, 2, n. N is number of trials, okay, fixed. So, here 0 otherwise. Here also we can check the properties of probability mass function. What is that? P of x is greater than or equal to 0, summation x is p of x is 1. So, if you take summation NCX p to the power of x q to the power of n minus x, we will expansion 0 to n, the binomial expansion, we will get total probability is 1. So, we proved binomial distribution is also discrete probability mass function. So, these are the density probability mass function, and its binomial mean is NP, variance is NPQ. Coming to Bernoulli, what? Mean is P, variance is PQ. So, that is why Bernoulli mean is P, binomial mean is NP, Bernoulli binomial, both have two possible outcomes, but Bernoulli is only one time we can do the experiment, but binomial we can do the trial repeated number of times. So, its mean is NP and its variance is NPQ. It is a very important point, okay? Please be note. So, here sample size is fixed in binomial and success is constant for each trial, that is P, and failure is Q, where P plus Q is 1. So, where we can use these binomial distributions? For example, number of defective units in a sample. For example, in business purpose we can use this sample selection. So, one can pack that article. So, if we get fully good items, no, sometimes it may be defectives, the defectives we can count. So, number of defectives units in a sample. Next, number of patients responding to treatment, number of people who answered yes to a survey, questionnaire, etc. For example, in questionnaire we will give 30 questions. So, according to the students they will answer yes. So, and some are answers no. So, out of 30 some may answer, we can say that is yes, and people who not answer, that is no. So, we can count out of n how many yes, how many no, also we can count. Yes termed as a success, no termed as a failure. So, it is also satisfies binomial distribution properties, okay? That is. So, here it is used in the construction of control charts and in acceptance samples. So, in quality control in business decisions we can use this binomial also accepting sampling plans. Now, one more example, this is very important. Rohit Sharma scored a century as an opener in 6 ODIs out of 10 he played last seasons. If he opens the innings in 10 ODIs in the season, what is the probability he will score 8 or more centuries, assuming he maintains the same consistency as in previous season? So, here we have to see what is the probability and what number of times he played the games, that is also important. In this problem, what is P here? 0.6. Why 0.6? Here scored a century as opener in 6 ODIs, out of he played 10. So, total games he played is 10 and he scored only 6. So, that is probability is 6 by 10, that is 0.6. Okay. So, here x means number of centuries scored in the present season, and now of ODIs and played in this season. So, what is the probability he will score 8 or more centuries, that is we need to find out. So, up to 8, up to what is the probability of success they have given, we need to find out more than 8. So, that represent here P of x greater than or equal to 8. That is, we know that fixed number of trials is 10, we need to find more than 8 centuries. So, then that is x equal to 8 to 10, that is 10 Cx p to the power of x q to the power of 10 minus x. What is here q? 10 p is 6 by 10, q means 1 minus p. So, 1 minus 6 by 10, that value is 4 by 10. Okay? So, that is here summation 8 to 10. Why you have taken 8 to 10? We need to find out more than 8, the random variable x more than or equal to 8. So, 8, 9, 10. If we expand this 10 Cx, 6 by 10 whole to the power of x, 4 by 10, 10 minus x. So, if we expand x plus 8 and 9 and 10, if you substitute 8 value here, 10 C8. What is NCR formula? N factorial by R factorial n minus R factorial. Okay? 10 factorial 8 divided by 8 factorial 10 minus 8 2 factorial. Okay? So, 6 by 10 whole to the power of 8, 4 by 10 whole to the power of 10 minus 8 is 2. Here common terms will be get cancelled, plus next 10 C9. So, 10 C9 here we can expand 10 factorial divided by 9 factorial 10 minus 9 factorial, 6 by 10 whole to the power of 10, 9, 4 by 10 whole to the power of 10 minus 9. Next 10 C10, 10 C10 is 1, 6 by 10 whole to the power of 10, 4 by 10 whole to the power of 10 minus 10, 10 minus 10 whole to the power of is 0. So, this whole to the power of is 1. So, if we simplify, we will get the value of probability of x greater than 8, which also lies in the limits 0 and 1. Every value, if you get 100 times, if you repeated coin in 5 times, 6 times, 10 times, and what is the probability of getting outcome? That lies 0 and 1 only. This is very important. You only yourself will check the answer. Okay? So, this is one more problem. Same, in a town, cab aggregator has 13 vehicles of the same model. The probability of that a car is hired is 0.8. The demands of the vehicles are independent. What is the probability all the vehicles are hired on a particular day? All of them remain idle. Here P is 0.3 and total how many vehicles? 13. Here we need to get exactly probability of x equal to 13. In the similar way I explained that binomial mass function is what? NCx p to the power of x q to the power of n minus x. If you substitute those values, we will get the answers. That is exactly x equal to 13, and second is all of them remain idle, that is x equal to 0. So, here we will get the values. Same in play of cards, one can know playing cards we have 52. So, here the problem, a deck of cards have probability of getting success is 1 by 2. So, 5 cards are selected with the replacement. What is the probability of getting? 3 and 2 black cards. So, here these are the examples are binomial distributions. Here fixed number of trials and success is constant for each trials. So, these are some questions. Or mean of binomial distribution is 4 and variance is 5, and the above statement is correct. So, we know that here binomial mean is greater than variance, but here mean is 4 and variance is 5. So, this statement is wrong. So, like this you apply and please practice these questions, so you will succeed in your examinations. And one more example here, the mean and variance of binomial distributions given here 4 and 4 by 3. Find the probability of x greater than or equal to 1. As I explained, binomial is NCx p to the power of x q to the power of n minus x. Here we need to find what is n, what is p. Okay. Here given mean and variance, we can divide it by mean by variance, we will get the n value. Okay. From that you apply NCR formula, we will get probability of x greater than or equal to 1. So, please practice all these questions, you will succeed in your examinations. All exercise problems and theory concepts are very, very important, and some additional also applications are there, that also we will explain. So, to construct control chart for number of defective units in a sample, or suppose a lot is accepted if there is one or less defective units in a random sample of n equal to 15. So, these are models, please go through successively. Thank you.